Hi everyone, welcome to AP Stats. This is the summer assignment. We are going to cover as much as we can for chapter 1 today. And then when you guys come in September, we're just going to start doing practice problems that are AP problems. And we're going to jump right into more of the note taking right now. So please make sure you take notes in the packet provided for you. We prefer paper so that it's easier to check in September. And this will count as a test grade if you complete this assignment. All right, so this year we're going to be talking about statistics, but what is statistics? We're going to be collecting data, analyzing data, and drawing conclusions about this data. So specifically, the people in a data set are called individuals, and these individuals could be made up of humans or animals or things. And we care about something called a variable, which is something about those individuals. And that variable is going to be something specific that we're measuring about them. So there are two types of variables we're going to talk about this year. They are categorical and quantitative variables. Categorical variables, another word for it is qualitative variables. And basically, these are not numeric. So we are taking people and we are putting them into categories based on something. So eye color, favorite pizza place, if you're a righty or a lefty, etc. It does not make sense to find the average of a categorical variable. Can't find the average eye color, for example. It doesn't make sense. Quantitative variables are numeric. They take on numeric quantities. It's a variable that it can make sense to find the average of. Examples include your height, your weight, your shoe size, your SAT score, etc. So that is the difference between the two. We spend more time talking about quantitative variables this year, but we are going to touch upon categorical variables. So if you're not sure if you can find the average of something, then it is a quantitative variable and it can be put on a number line, an axis, and you actually count it out with numbers. It's quantitative. So this year we're going to talk about how we're going to we want to know about a population, which is the bigger group, the larger group of people. So maybe like all people in Valley Stream Central High School, we want to know about how many hours of sleep they get on a typical school night. But it doesn't make sense for us to ask everyone in the population. So we're going to take a sample from the population, and hopefully the sample is a good sample and it's going to represent the population well. So we take a small sample from the population, we collect data about them, and then we graph everything and we analyze it, and then we try to make an inference about that bigger group. And that's what we're going to be doing all year. We're going to get data from a sample, graph it, describe it, analyze it, and hopefully make a good generalization about the overall population. Okay, so let's start with categorical data. There are a couple of ways to graph categorical data. We can put it in what we call a two-way table, which you guys saw if you took Algebra 2. You can put it in a pie chart or a bar graph. And let's go into those right now. So here we have a table. This is sorting some individuals from Canada into categories. What province they're from, meaning it's almost like states in Canada, the provinces, that is a categorical variable. What gender they are, that's a categorical variable. The number of languages they speak, that's quantitative because it's numeric. If they're righty or lefty, categorical. Their height, numeric, quantitative. Their wrist circumference, quantitative. And what kind of communication do they prefer? Putting people into a category based on that, categorical. So let's start by talking about categorical variable here, preferred method of communication. They asked these people, how do you prefer to communicate best? Using your cell phone, your Facebook, in person, or text messaging. So then what they did was they made what we call a frequency table, which is down here. and they counted up how many people said cell phone, how many people said Facebook, etc. And then they took it out of the total. So there were 10 people total, and they did the percent of each category. 2 out of 10, 1 out of 10, 3 out of 10, 4 out of 10. They got those percents, and then they were able to graph those in the form of those two graphs that I mentioned before. This is a bar graph showing that data of that variable, and this is the pie chart. Both of these you're going to see a lot in the news media because they're pretty common. The bar graph, the bars don't touch. So keep in mind that if the bars don't touch, that is a bar graph. The x-axis is the variable that we're measuring, which is the preferred communication method. And the y-axis is the percent breakdown within that categorical variable. So with one quick glance, we could see that the greatest percent of preferred communication is text messaging, followed secondly by in-person, thirdly by cell phone, and lastly by Facebook. Now, if we were to look at the pie chart, this is displaying the same exact data, it's just in the form of the pie chart. It's kind of harder to make the pie charts by hand because you would have to get a protractor, measure the angle, and figure out the ratio out of 360 degrees. But these are often used in the news media. But again, you could see the same information here. The greatest percent or proportion of people who are preferred method is text messaging. So now I want you to look at this example down below. It's going to ask you about some individuals, and they ask them a bunch of questions, and I want you to write down who are the individuals or what are they if they're not people. And then I want you to identify the variables like I did above and state if each one is quantitative or categorical. You can just write on the top C for categorical or Q for quantitative. So stop the video here and do that now. Now we're going to talk about how we can organize and analyze the data on the two categorical variables. So what if I took two variables and I wanted to put them against each other? The two variables that they picked here were, are you a member of the environmental club, yes or no? And have you ever used a snowmobile? Have you owned it? Have you rented it? Or have you never used it at all? So a two-way table is a way to display two categorical variables. And you guys have seen this if you were in Algebra 2 because we went over how to do this and how to find probabilities. So there are two variables here. There's a row variable and a column variable. The rows go across like rows in a movie theater, and the columns go up and down. Like think about the columns of the White House, up and down. So in this case, they asked the people, have you ever used a snowmobile? There are 3 rows here. And are you a member of the environmental club? 2 columns. So we say the rows first, 3, and the columns second. So this is a 3 by 2 two-way table. Now, as you can see here, the totals were not included on the bottom or on the right-hand side. So if you don't see totals, you need to find the totals yourself. You would add up the columns and write them in here and here, and also add up the rows and write the totals in here. Okay? And then on the bottom right is going to be the total, which is the total in the sample. So basically you need to know if they asked, it turns out they asked 1,526 people these questions. That number is going to be on the bottom right hand side. So the total in the sample is always on the bottom right hand side. And then these other totals are called marginal distributions because they go in the margins. Okay? So total in the sample. That's what you need to know is write in the totals. If they're not there, you have to find them yourself. So now we can find the percent breakdown of just one variable or 2 variables. We're going to start with one variable. What percent of people surveyed never used a snowmobile? So if I just want the breakdown of only snowmobile use, never renter or owner, I would look at, in this case, never, the never total, which is 657. And I would divide it by the total, which is 1526. So never total over total. And then I would get the percent. Okay, so do that now. 657 divided by 1,526. We get about 43%. Okay, so similarly, we could do the breakdown of every single one. I could do renter and owner out of 100, and I could just have made a bar graph or a pie chart on snowmobile use. Separately, I could also do the percents of are you a member of the environmental club or not. So what percent are not members of the environmental club? I will look at no total, and that's going to be 1221 out of total 1526. No total out of total, and I would get that percent as well. So let's do that now. 1221 divided by 1526, we get about 80%. Okay, so that means this breakdown is going to be about 80-20 when it comes to if you're a member of the environmental club or not. So as you guys could see on the bottom here, that's actually what they just did, is they computed the no total and the yes total 80-20 like we just did, and that was the breakdown here, 80-20, and I could just have made a pie chart or a bar graph on that. Or I could have done the row breakdown of never, rent, and own like we did. 43%, 37, 19, and I could have done a separate pie chart or a bar graph on that. Okay, so it depends on which variable you're spotlighting. Now, the other thing we could do is look at joint frequencies. When you think joint, I want you to think you're a member of both groups. So that is actually called the intersection. And you guys learned about intersection in Algebra 2. The formula, the symbol, sorry, for intersection is this symbol here, and it means and. So if you are a member of both groups, you're in the intersection. So this says, what percent of people are environmental club members? So yes, they're environmental club members, and they own snowmobiles, all right? So the notation you learn in Algebra 2 is yes, environmental club, and this is the symbol for and. It looks like an tunnel, or you can make an A out of it for and, right? Intersection, and own. All right. So where does yes and own meet? Where does yes and own meet? Here's yes, here's own, and where my color changed was 16. So that is the intersection, 16 out of the total. All right. Now you try this one. What proportion of people in the sample are not environmental club members? And never use snowmobiles. Okay, pause the video and write that down. Now, the next thing that they may ask you is called a conditional relative frequency. You also learned this if you took Algebra 2. So what if they put a condition on the denominator? Instead of going out of the total, what if we went out of the row total or the column total? So for example, look down here, it says example 1, what percent of environmental club members in the sample are snowmobile owners? So the key word here that you're going to look at is the word of. The word of is indicating that whatever comes after the of is going to be in the denominator of the fraction, and that's actually going to be the pool of people who I'm taking out of. So out of the environmental club members, so out of only this column here, the 305, how many of those people are snowmobile owners? So you're restricting your denominator to only the yeses, and out of those, how many of them are snowmobile owners? There's 16 of them, okay? So the conditional relative frequency is saying that you're going to change your denominator of your fraction or your pool of people that you're taking out of to whatever comes after that buzzword. The keyword, okay? So it's not out of the total anymore. So of the environmental club members means you're saying restricted to only in the environmental club members, and out of those, how many of them are snowmobile owners? Okay, you guys learned that this is called conditional probability in Algebra 2. And some other keywords that you may keep an eye out for are, besides of, given that they are an environmental club member, what's the probability they own? Another one would be among the environmental club members, what's the probability or what's the percent of people who own? And the last one, of, among, given that, if they own, what's the probability they're environmental club member? So whenever you hear any of these keywords, those indicate that you're restricting your denominator. Instead of out of the total, you're going to look out of the row total or the column total, whatever comes after that keyword, row or column total. Okay, so let's look at example 2. 1b, sorry. What percent of those who have never used snowmobile are in the environmental club? So of those who have never, out after the word of, never comes next. So never used snowmobile are in member of the environmental club. Okay, so I want you to restrict your denominator to the nevers. I'm going to highlight it here in green. Here we go. So how many people never use the snowmobile total? 657. Out of those, how many are a member of the environmental club? 212. Okay. And then we could get the percent. 32-ish percent. So I want you guys now to try this example, to try the whole thing, A, B, C, and D. It's going to ask you either to go out of the total, the row total, the column total. It might ask you for a row probability, a column probability, a joint probability, or a given that probability. So look for the keywords and try A through D. Stop the video here. Now, how do we graph this two-way table? Well, there's a couple of ways. We could make a side-by-side bar graph, like is shown here on the left, or the preferred method, which is more on the AP, is to do what we call a segmented bar graph. So when you think segmented, I want you to think about like the segments of the earth. Think about sedimentary rock has segments, and those are layers, right? So basically this bar graph relates the two variables to each other, and they're both categorical variables, okay? So if you look, they choose one of the variables. In this case, they chose the environmental club membership to be the x-axis. And then they have yes and no, which were the only two options for environmental club membership, yes or no. And then they do the row breakdown, which there were 3 rows, right? The 3 rows were never use a snowmobile, rent a snowmobile, or own a snowmobile. So they do the row breakdown within the yeses and within the nos out of 100. So basically what they would do is they would go to the no environmental club column, and they would do the percent of the never, the rent, and the own out of the nos. And then they would display it in the form of these segments. So it looks like, for example, this blue key, you need a key for this. The never is blue. So it looks like there's about 35% who, out of the people who are not a member in the environmental club, never use a snowmobile. Now to get the next segment, which is those who rented, that's the red, I would have to subtract, because this is 35 and this is about 75. I would have to subtract 75 minus 35 to get the percent of renters out of the nose. So that's going to be about 40%. And then the remaining green, which is the own, would be from 75 to 100, so that would be about 25%. So you basically add the segment on top of each other to create the segmented bar graph. Now, what are they looking for from this? On the AP, they want to know if there's a relationship or an association between the two variables. So another word for association is there a relationship or a correlation between the two variables, okay? So do they influence each other? Do they impact each other? So if you are a member of the environmental club, do you guys see that this blue region here is about 70%, is greater than the blue region in the nose? So basically, if I know someone is a member of the environmental club, it is more likely that they're never going to use a snowmobile than those who don't. This indicates that there is an association between the two variables because there is a different percent breakdown across bars. So if you see that the segments look different as you look across the bars and the segment breakdown is different, this indicates that there is some kind of relationship between the variables. So different segment percent breakdown across the bars. So think about it. Do I know that if I care about the environment, I may be more likely to never own a use a snowmobile? Yes, because if I care about the environment, maybe I don't want to waste fuel on the snowmobile. So there is a relationship between my love of the environment and my not wanting to use gas on a snowmobile. Versus if I know that I'm not a member of the environmental club, I'm actually more likely to own a snowmobile because the green segment here is greater than the green segment here. Now, there is no association between the variables if the segments look exactly the same across the bars. I'm going to show you what that looks like in a second. If you see a segmented bar graph, I'm going to show you an example here. Let's say it said yes and no here, percent here, and the two bars go up to 100%, and the bars looked exactly the same. Black, black, polka dot, plaid, plaid, whatever. And you see, like, doesn't matter if you're in the environmental club or not, the percent breakdown of those who own or don't own a snowmobile is exactly the same. This means no association between the variables, meaning if I know that you're a member of the environmental club, it doesn't matter. Your snowmobile use will not be influenced or impacted. Now, on the AP, they might ask you to describe the association that you see. If they ask you to describe, we don't want to just make a few sentences based on what you think. What you want to do is pick two segments and compare them across the bars. So what do I mean by that? Let's say I was looking at the blue segment, which is the nevers. I would say there is a greater percent of people who have never used a snowmobile for those that are members of the environmental club than those who are not. Then you pick a second one. You pick maybe green, own. There's a greater percent of people who have owned a snowmobile and those that are not member of the environmental club than those who are a member of the environmental club. Notice I'm using the word greater than or less than. Those are comparative language. Comparative language. So you want to use the word greater than, less than, equal to, approximately equal to, and you want to compare two or more segments across the bars. So I picked blue and I picked green and I'm comparing them across the bars. You don't necessarily want to make a statement within each bar. You could, but they're not looking for that. They want you to make a comparison across the bars instead. Another tip that I want you to note is that when you compare across the bars, you don't want to use the words like more or like a greater amount. You actually want to use the word percent or proportion. And the reason why you want to do that is because they might be out of different totals. So if you say the word greater than or greater amount or greater amount of people and you use the frequencies, it actually may be misleading because if you look back at this, there's a greater percent of people who have never owned a snowmobile in the yeses than the nos. But if you look back at the example on the previous page, the number amount is actually less in the yeses than the nos. 212 is actually less than 445, but when you do the percent breakdown, because it's out of a smaller total, it winds up being a greater percent. So don't use the word there's a greater amount. You have to say a greater percent or a greater proportion. That's really important, and that's what this exam tip is saying. All right, so now here's the AP question. We want you to try it now. So I want you to read it and I want you to answer the question down below. This is an actual AP question. They asked these people, 100 people specifically, in a sample, two questions. Do you participate in extracurricular activities? And you see that there are 3 rows here. 3 levels of participation of extracurricular activities. And they also asked them, do you live on campus or off campus? So there's 2 columns here. Notice the total is on the bottom right hand side of the page. So first it's going to ask you to find the percent or proportion of these. for part A. And then it shows you that they created a segmented bar graph for you. And notice this one is horizontal instead of vertical, and that's okay. The percents are on the x-axis here, and the y-axis is the residential status. And then they created a key on the side, and the key is showing the um, level of participation of extracurricular activities within each group. So there's 3 segment percent breakdown within the on campus and 3 within the off. And it says write a few sentences summarizing what the graph reveals about the association. So I want you to say, is there an association or not? Yes or no. Is there an association? Is there an association between the 2 variables, yes or no? And then what you have to do is write a few sentences, and specifically when they say a few, they're looking for 2 sentences or 2 comparisons. Pick 2 colors, basically, okay? And compare the none to the none, or the 1 to the 1, or the 2 or more to the 2 or more, and use comparative language. So use the word greater than, less than, or approximately equal to across the bars. Across the bars. Okay, stop the video here and complete this question before we move on. Okay, the next thing we're going to talk about is quantitative data. Quantitative data, we said in the beginning, is data that is numeric. So it takes on a numeric value. Now there's a bunch of different ways that we can graph quantitative data. The first one is called a dot plot, and you guys may have seen a dot plot in Algebra 2 or in the past. So a dot plot basically puts a dot representing each individual observation. Each individual observation is graphed with a dot. And the reason why this is nice is because every individual is actually represented. So as you can see here, they had the number of games of a season of the U.S. women's soccer team, and they measured the variable of the number of goals scored. So again, it's a quantitative because it's a numeric quantity. It makes sense to put it on a number line, the x-axis. So what we would do is draw the x-axis. We would put scale the axis appropriately. So you don't want to count like by weird numbers. You want to count 0, 1, 2, 3, 4, 5. You don't want to skip numbers. Don't skip numbers. Even though I have a gap between the 5 and the 9, I don't want to skip numbers here. And then what I want to do is I want to place a dot kind of floating over each number representing the observation. So if I were to read this, you want to try to make the dots kind of evenly spaced as well. This is showing you that there's 1, 2, 3, 4, 5. There were 6 games in which the U.S. team scored 1 goal, okay? There were 1, 2, 3, 4, 5 games in which they scored 2 goals. There were 3 games in which they scored 3 goals. There was 1 game, 4 goals. 3 games, 5 goals. Then there were no games where they scored 6, 7, and 8 goals. There was 1 game in which they scored 9 and 1 game in which they scored 10. So we can describe the shape of the distribution by using the words either symmetric or skewed. Symmetric or skewed, okay? We can also use the words uniform, and we can use the word bimodal or unimodal. And we could also use the word gap. All of these words play a role in describing, okay? So let's start with the basics. This first one is symmetric. Now, is it perfectly symmetric? 2, 2, 3, 4, no. We call this approximately symmetric because it's not perfectly symmetric. So if I folded this paper in half, it would be almost perfectly symmetric, but not quite. So you throw in that word approximately symmetric. Now in Algebra 2, you guys also said that it was bell-shaped, and it is. There is one mode, which means the highest peak is only at one value. So that is called unimodal. Okay, one mode. Now, if we look at this next one, we call this one skewed. And where is it skewed? It's skewed in the direction of the tail. So I want you to picture this as like a whale or a fish, and it has a tail. Wherever the tail is longer at is the direction of the skew. So because the tail here is on the right, this is called skewed right. And basically most of the observations are on the left, but there's a few that are rarer that are on the right. And the concept of being skewed is that the average or the mean is being pulled in the direction of the skew. So this is skewed right because the mean will get pulled up by those rare observations on the right. Wherever the tail is the direction of the skew. This next one here, if you look and if you were to draw a tail, the tail is on the left. So if this were a whale or a fish with a tail, the tail would be on the left. So this is skewed left. This actually means that most of the observations are on the right, but the tail is on the left. So if you go back to this question here, you guys should see that there is a way longer tail on the right-hand side, and thus this is skewed to the right. Okay, so that's the concept of describing. Now, a few more words that I had mentioned up top that were not represented. The first one is uniform. If you see uniform, it means that all the dots would actually be the same height. So, example, dot, 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 3, 3, 3. This would just look exactly the same. If you had drawn it into a curve, it would look like a straight line going across. All the bars are the same height. That is called uniform. And then bimodal means two modes. So that would be something like at 1, there would be 5 dots. Then maybe at 2, it would go down, 3, 4, 5. And maybe at 5, there were 5 dots. So two modes means bimodal. You see there's 2 peaks, 1, 2. 2 peaks. Okay. Now, you see this question again. This is the same one. This says describe the shape. So we want to say the direction of the skew. It is skewed left. We also want to say the context. So this was the number of goals scored in the 20 games played by the U.S. Soccer team in 2016. So we will want to say that. We want to say the number of goals scored by the U.S. women's soccer team is skewed. Oh my goodness, I said skewed left. It's skewed right. I hope I didn't say skewed left on the previous one. No, it's skewed right. Good. This is the right-hand side. It is skewed right. Now, let's talk a little bit more about this. Most of the time, the U.S. women's soccer team is scoring about 2 goals per game, right? But there were a few rarities, that they scored 9 goals or 10 goals. These are called outlier games because they're separated from the pack. So these are rarities, but what happens is these outliers pull the mean or the average up. The average gets pulled to the right or in the direction of the skew. So it is skewed right because the average is going to be pulled up. So maybe they would say the average number of goals scored is 5, and you'd be like, oh, they must be scoring 5 goals per game. And in reality, they're really scoring like 1 to 2 goals per game, but the average got pulled up because of that 9 and 10. Now, the other thing that we want to say is there's a gap. So there is a gap between the 5-goal mark and the 9-goal mark. So we want to say exactly where the gap is located, okay? So with a gap between 5 and 9 goals scored. And then we also want to say how many outliers there are. With 2 outlier games of 9 and 10 goals scored. Now notice I'm throwing in the words goals scored, goals scored, goals scored. And I'm doing that because we need to have context. Okay, so pretty important. You don't want to just list bullet points here. You want to kind of put in the context of the question. So let's sum it all up. The distribution of goals scored by the U.S. women's soccer team in the year 2016 was skewed to the right, with a gap between 5 and 9 goals scored, and with 2 outlier games of 9 goals scored and 10 goals scored. Now let's move on to stem plots. Back in the day, stem plots were also called stem and leaf plots, and you may have seen them in the past. How do we make a stem and leaf plot? Well, what we do is I like to put all the observations in order from lowest to highest, and then we draw a vertical line, and the vertical line is one like this, boom, boom, and we separate the stems and the leaves. So this is the stem, and this is the leaf. Stem, leaf, stem, leaf. In this case, it looks like we had double-digit numbers or two-digit numbers. So it looks like the stem is the tens place, and the leaf is the ones place. So I'm going to write that down. Stem is, in this case, the tens place, and the leaf is the ones place. This does not necessarily have to be the case in every question, depending on the units. If we have big units, small units, hundreds, thousands, etc. But in this case, this was tens and ones because of the case of they asked for the number of pairs of shoes that these people owned. So that's why we use the stem and leaf unit of tens and ones. So what they do is, let's say I own 49 pairs of shoes. Whoa, that's a lot. To represent 49, I would put the 4 on the left to represent the 40, and the 9 on the right of that line to represent the 9, which is the ones. So 49 is broken up into 4/9, but it really means 49. So 1/3 means 13. Now you may notice that there's actually 3 3s over here on the right. These 3 3s actually indicate that there were 3 people who owned 13 pairs of shoes. 1, 2, 3. And those are represented by the 3, 3, and 3. So each person or each observation is represented with a leaf. And I want to write that down here over in the box. Each observation is represented with a leaf. So the stem kind of serves as more than one observation because there was more than one that had a 1 for the first number. There's 13s, there's 15s, and there's 19. But the leaves on the right-hand side, that is what you're really looking at to count up how many people were in that category. Okay, so if you wanted to describe the shape of this, you would kind of turn your head and you would almost get a visual of what this would look like if this had been a curve. And you see that it looks like most people are in like the 20s, between 20 and 26 number of shoes owned. But there's, you know, only one person who had 49, and then there were a bunch of people who actually had 50 or more, which is pretty crazy, but maybe that's you. So good for you. Now, also note it's important to have a key because the key tells you what exactly you're reading, okay? So on the top here, it says the steps. Do we really have to make a stem plot? In the past, we did a few times. I feel like they're moving away from that more, but if you are making one, it's really important that you provide the key so you can actually identify what the stems and the leaves really represent. All right, now let's look down below. There it may be that you see what we call a back-to-back stem plot. A back-to-back stem plot displays two groups. In this case, the groups are males and females, and on the same variable, measuring the same variable. And you're basically placing them on the same stem, and you're just, this middle here is the stem. And then the leaves are either males or females. Leaves, leaves. Okay, so like the thing here is that when you're looking at it, one of them is straightforward and the other one winds up being backwards. So when we look at the males, for example, this 3, 5 for the males means 35 pairs of shoes, if we're still talking about pairs of shoes. Okay, for the males. But for the females, it's actually backwards. So if I were to look at this 8 and 3, this actually doesn't mean 83 because you have to read from the inside to the outside. You have to read stem to leaf. So this actually 8/3 for the females, it's actually reverse. It means 38 pairs of shoes. Well, and for the females. So just be careful because whichever one you're reading from left to right is the straightforward one, and then the other one winds up being backwards, all right? So if I were looking at this one, I would want it to describe the shape of the males. If I turn my head to the side, I would see that the males is skewed to the right because there is a gap. Most of the data is towards these lower numbers, and then there's a gap here, and then there's a few outliers here on the right. So the males are skewed right. But now if I wanted to look at the females, I have to be careful because when I turn my head the other way and I'm analyzing it, it actually is also skewed toward the bottom here, but you think it looks skewed left, but because that number line here is backwards for the females, it's actually the reverse of what you think. It's skewed right as well. So that gets kind of hard or tricky. So you just have to think about it's skewed towards the bigger numbers is a way to say it, which means skewed right. All right, so this says, note, be aware when comparing two distributions using the back-to-back stem plot because the left one is actually backwards compared to the one on the right. So here is an AP question. I want you to take a look at it and I want you to try it. It was a multiple choice question as you could see. So take a look and see if you can answer the question. Okay, let's go on to histograms. Now, a histogram is basically taking that stem and leaf plot and making them into bars and making those bars touch. So really important, the bars touch, okay? Write that down. And that is different from the bar graph because the bar graph, the bars did not touch. With a histogram, it is measuring a quantitative variable, so it looks kind of like a bar graph, but it's actually, the bar graph is for the categorical variable. Now, the key with a histogram is that the individual values are not represented because unlike the dot plot and the stem and leaf plot, with the histogram, we are going to place each individual into a category or a range of values, okay? Each value is placed into an interval or a range of values. Okay, so I want you to back it up to that stem and leaf plot for a second. All right, I'm going back to that because it is going to lend itself to the histogram. Do you see how the stem, in this case, is actually the ones place? So it's really the tens place. This is really 10 to 19. And then this next one is really 20 to 29. And the next one's really 30 to 39 and 40 to 49. So if I had placed these people, instead of writing the exact numbers, into class widths, they're called class widths or intervals, and I connected these and made them into bars, if you turn your head, if we make the bars touch, now it becomes a histogram. So these intervals would actually be 10 to 19 pairs of shoes, 20 to 29 pairs of shoes, 30 to 39 pairs of shoes, 40 to 49 pairs of shoes, and 50 to 59 pairs of shoes. This would be the interval range. Another name for it, again, is class width. And then what we could do is make a frequency table counting the number of people who fall into each category. So 1, 2, 3, 4, 5. There's 5 people in this first leaf, right? Stem, sorry. Next one, 1, 2, 3, 4, 5, 6. 6 in the next one. 1, 2, 3, 4 in the next one. 1. And in the last one, 1, 2, 3, 4. So once you count the number of people that fall into each category or class width, then what you would do is make your x-axis, and instead of making your x-axis a single number, you make it an interval along the axis. Okay, you see these here? And then you would, on the y-axis, you would put the frequencies or the number amount. that fall into each bar, okay? So here is a different example. And if you look, it says this is the frequency table associated with it. So they took the class width or the interval ranges and they put them over here, and then they counted the frequencies of how many people land in each one of these categories, okay? So there are 20 people in this first bar, and look over here across, this is 20. So this is the frequency associated with this first interval, 0 to 5, okay? You could write 0 to 5 here if you like, or you could just write the endpoints 0 and 5 like they did. The next one, there's 13 people in the next bar. Okay, so now I have 20, 13. Next one, 9, 5, 2, and 1. So can I see, if I look at this histogram, exact data points? The answer is no. I just know there's 20 people in this bar, but I don't know who they are. I don't know if the 20 people in there are 1%, 2%, 4.9%, 3%. I actually have no idea what the individual data values are at all. I just know they land between 0 and 5, okay? So what's nice about a histogram is you can easily see the shape of the distribution, and the shape of the distribution of this is, can you guess? The tail is on the right, so it is skewed right, with most of the data lying between the 0 and 5% mark, right? But you can't actually tell like what the actual data is for each, if these were states for each state. So that's what it says down here. Important note, we can't see the individual data points at all. So we actually don't know the exact range. We don't know the exact median. We don't know the exact maximum. We don't know if this maximum is actually 30. We don't know if this one state, for example, we don't know if this is 30, if this is 29, if this is 25.6, 27. I actually have no idea. I just know that the maximum it could be is 30, but I don't know the exact maximum. I don't know the exact minimum. So I don't know the exact range. I don't know the exact median. I don't really know anything exact from a histogram at all. So that is a disadvantage of the histogram. And this has shown up in the form of a multiple choice question on the AP. Okay, now let's go to center. You probably have heard these words before, so I'm going to go kind of quickly through this. We have mean, we have median, and we have mode. The mean is another word for the average. And the average is where you add everything up, and then you divide by the total in the sample. Okay, the calculator actually finds this for you, and I'm going to show you that now. So if you have a calculator, great. If you don't have a calculator, it's okay. You could just look on with me. I think some of you have your calculators set up on your computer, so you want to do that this year. So what you're going to do is you're going to want to enter your data in your list, calculator. Enter your data, if it's just in your list L1, for example, in L1. To do that, you're going to press Stat, Edit, and then you would enter your data, okay? Let me clear my list here, and then I'm going to show you. Let's say I had number of goals scored for the U.S. Olympic team, and I had 1, 1, 1, 1, 1, 1, 2, 2, 2, 2, 2, 3, 3, 3, 4, 5, 5, 5, and then there was 8 and 9, I think. Okay, or 9 and 10. Sorry, let me do that again. 9 and 10. Okay, so let's say I wanted to find the median. What I would do, or the mean, sorry, the mean, the average. What I would do now is I would press Stat. So just so you know, I pressed Stat Edit first, and I entered my data into L1, which I wrote, okay? Now you're going to press Stat. You're going to go over to the right to where it says Calc. Okay, let's do it. Stat, go over to Calc, and you're going to choose number 1, 1 var stats, okay? And you want to make sure it says L1 for the list and nothing in the frequency list. So here it says L1. I don't want anything in the frequency list because I don't have anything in L2. And now I'm going to hit calculate, boom. And now you want to look for this first number here on the top. For me, it says 3.15. That is called X bar, okay? So the symbol for mean is X bar. It's actually x with a bar over it, x bar. And again, if you took algebra 2, you guys would have seen it before, okay? So you see my average here is 3.15. Indeed, that is the average here. It's represented there. Now, please note that average got pulled up in the direction of the skew. So remember, because this was skewed to the right, the mean or the average got pulled to the right. So most of the time, the U.S. women are scoring 1 to 2 goals per game, but because that average got pulled up because of those outlier games, that average is not really representing the truth of what they're really scoring per game, okay? Now this says, here is the mean number of goals if we excluded those outliers. So if they took out the 9 and 10 goal game, which you see here now, they removed it, look at what the new average is. Do you see it's 2.44? It's much less, and that's more representative of what they really do per game. They score about 2-ish goals per game. So what we need to say about the mean is that the mean is not resistant to outliers. The mean is not resistant to outliers. And what does that mean? It means that the mean gets pulled in the direction of the skew. So a statistical measure is called resistant if it is not impacted by outliers. Okay, let's talk about the median. The median is the middle number in the data set. The median is the middle number in the data set. Do you think that the median is going to be impacted by those outliers? I'm hoping you're going to say no. So I'm going to show you how to find the median now. The old median actually is right on your computer screen after the mean. If you scroll down with their little down arrow, do you guys see it says median, M-E-D? M-E-D. The old median for that data with the 9 and the 10, I'm going to write it down. The old median was 2 goals scored. It was right here. It landed in this bar, okay? Now, what happens if I remove those outliers? Let's see. I'm going back to stat edit, and I'm going to go to the bottom of my list, and I'm going to just hit delete on the 9 and the 10. And now I'm going to run the one variable statistics again. Stat, calc, 1 bar stat, L1, calculate. So my new mean was 2.44, which is what it said here, 2.44 without the outliers. And then if you scroll down, do you see the median is still 2? Aha! Median is still 2. So the median is not impacted by the outliers because it's in the middle, and the outliers are not in the middle. The outliers are on the end, all the way on the right. So they're not going to really affect the median very much. So the median is resistant to outliers. It's not impacted by the outliers. Now there is a formula for median, and the formula is, now yes, you could just literally just sort them all out like this from low to high and go like 1, 1, 1, 1, 1, 1. You guys probably learned how to do this back when you were a wee little lad or less. And just look for the 1 in the middle, right? And if there were 2 in the middle, you guys remember you would find the average of the 2 in the middle. Well, the formula for this, which is quicker than doing that, is you do n plus 1 over 2, where n is the total number of observations in the data set. Let me explain. So in the old one, when they had 20 games, before I removed the outliers, okay, 20 games, the n would be 20, okay? So I would have done, for the median location, I should say this is the location of the median, not the actual median. So I would do n plus 1 over 2 to get the location of the median. 20 plus 1 over 2 is 21 over 2, which is 10.5. Now this does not mean that the median is 10.5, because the median wasn't 10.5, it was 2. It means that the median is located between the 10th and the 11th observation. So the 10th number was here, the 11th number was here, The average of the 10th and the 11th wound up being 2. So the location of the median is going to be this formula here. So down below, I want you guys to answer the question, which measure of center is resistant to outliers, the mean or the median, and explain why. Do that now. Stop the video and do it now. Fill it in. Now, let's say we're looking at a graph and we're looking at the shape and we're not quite sure if it looks skewed and which way it's skewed. Like, we can't really eyeball it. What we can do is look at the mean, and wherever the mean gets pulled is actually the direction of the skew. So if the mean gets pulled to the right, it's skewed right, and if the mean gets pulled to the left, it's skewed left. So wherever the mean moves is the direction of the skew. Okay, and that's what it says down below. To locate the mean, look for the direction of the tail. The mean will be pulled in the direction of the tail or the direction of the skew. Okay, so if the mean is around exactly equal to the median, or about approximately equal to the median, then the graph is approximately symmetric. If it's exactly equal to the median, then it is symmetric. And if it's approximately equal to the median, it's approximately symmetric. If the mean is greater than the median, then the mean is getting pulled to the right. So then it is skewed right because the tail is on the right. So the mean got pulled to the right, skewed right. And if the mean is less than the mean gets pulled down in the direction of the skew. The tail is on the left, the mean gets pulled to the left, then it is skewed left. So if you can't tell visually if it's skewed left, skewed right, symmetric, look at the mean, look at the median. Wherever the mean gets pulled is the direction of the skew. Now I'm going to take you through doing this question. It is going to ask you to find the mean, find the median, and do a few things subsequently. But before we do, let's remind ourselves how we're going to do this. We're going to use our calculator and we're going to enter the data in our list. So to clear your list, you press second plus sign, and I go to number 4, which says clear all lists, and I hit enter, and it will say done. Now I press that edit, and in L1, I'm going to enter in my data. So do that now if you have a calculator or an online calculator. And we'll make sure that all the data is entered correctly. Okay, so I should have 10 data points. Just checking to make sure I have everything in there. I should. Okay, so now what we're going to do is we're going to run the one variable statistics on the data. To do that again, we did it before. We're going to press stat. We're going to go over to calc, and we're going to choose number 1, one variable stat. And then you're going to hit enter on L1 and calculate. Okay, so now let's look at the mean, the median, etc. Okay, so the mean is on the top, x bar equals 8. That's the mean. And then it says the posts of 15 and 16 are possible outliers. What if we were to find the mean of the 8 others if those were removed? So if I were to remove those, stat edit, I would hit delete, not clear, just hit delete on those 2. Now I have 8, and if I do stat calc 1var stat, what do you think is going to happen to the mean now? Okay, do it now, write it down. And then it's going to ask you to find the median of the original data. Okay, so the median of the original data, what was it? And then can you compare the mean to the median? Are they equal? Is one greater than the other or not? And if it is, what is going to be the shape? Okay, so just to say that again, we found the mean to be 8. I should have really told you guys to find the median as well if I re-enter these numbers here. So I'll re-enter 15 and 16. Stat calc 1var stat L1, calculate, go down to the median, and you see the median is 7.5. Okay, so look at the relationship right now between the mean and the median, and how is that going to tell me about the shape? So when you go to D, tell me about the mean and the median, and then what is going to be the shape of this data. If I had graphed it, what would it be based on what we just learned above? Next thing we're going to talk about is spread. So we talked about shape, we talked about center, now we're going to talk about spread. Another word for spread, or how spread out the data set is variability or variation. So basically, is my data all consistent or is it all spread out all over the place? So spread can be measured by range, standard deviation, and interquartile range. Let's start with range. Range is defined as the maximum value minus the minimum value. If there is an outlier, the maximum or the minimum is incorporating that outlier, so the range is not resistant to outliers because we're including those outliers when we do maximum minus minimum. So here's my data, the same data from before. The range is going to be maximum minus minimum. So the maximum was 10, the minimum was 1. 10 minus 1 is 9. So the range of the number of goals scored by the women that year for the U.S. women's soccer team is 9 goals per game. But because that range incorporated that outlier game of 10, it is not a resistant measure of spread. We can also use standard deviation, which we talked about in Algebra 2. So standard deviation actually measures the on average, the distance or deviation, which is like the distance of each x value from the mean. The average deviation from the mean. Now the mean is the average, so we're actually finding the average deviation from the average. So basically, I'm going to give you a real life example. Let's say I'm someone who's very consistent. I get an 85 on every test. 85, 85, 85, 85, 85. Well, then my mean would be 85 because I get an 85 on everything. So my average is 85. And then my standard deviation, which is S sub x, would be 0 because everything is at the mean. Nothing deviates from the mean. Everything is the same. So I don't deviate at all from my mean. I'm very consistent versus someone like you you're kind of unpredictable. Maybe your average is 85, but maybe on one test you're getting 100, on another test you're getting a 70, next one 80, next one 60. You're all over the place. You're going to have a bigger deviation because you're going to be more unpredictable. One test is 20 points above the mean, one point is 20 points below the mean. And basically, what is the average of all those deviations from the mean? That is the standard deviation, the average deviation from the mean. Okay? It is not resistant because the more variable or the more spread out that the data set is, the more all over the place, the bigger the standard deviation. So on the AP test, a few times they have asked kids to interpret what the standard deviation means in the context of the problem. So here's an example. 11 high school students were asked how many close friends they have. Here are their responses: 1, 2, 2, 2, 2, 3, 3, 4, 4, 4, 6. To interpret in context, what would we say? So they computed the standard deviation, which is called S sub x. And that actually is something I should have written in here. Standard deviation is the symbol S sub x. It says it here as well. That is the sample standard deviation. And they got 1.34. So what does this mean in the context of the question? So we say on average, and then we put whatever we're talking about. So the number of close friends a high school student has deviates by 1.34 friends from the mean or average. So the average deviation from the mean is 1.34 friends. So whatever the mean was, let's say the mean was 3, then maybe it's plus or minus 1.34. So on average, people are around 3, but maybe they're around 4 or 2. But the average deviation from the mean is about 1.34. which I know is not a whole number, and that's okay. Now, sometimes we talk about variance in this class, and variance is just the standard deviation squared. So if you ever see the word variance, it's just also a measure of spread, and it's just taking the standard deviation and actually squaring it. So let's say I had 1.34 was the standard deviation. If I squared it, the variance would have been 1.7956. And that's just going to take away the negatives. Well, standard deviation is not negative, so variance is just something we're going to use later in the year. Another measure of spread that we're going to talk about is called the interquartile range. The interquartile range is just like the regular range where it's maximum minus minimum, but the interquartile range actually represents the middle 50% of the data. And to get it, we do quartile 3 minus quartile 1. We're going to talk a little bit about that in a minute, but the interquartile range is a resistant measure of spread because it just measures the middle range of the data instead of the maximum and the minimum, which include the outliers. All right, so let's say I'm ready to make a box plot. Soon enough, we're going to make a box plot. I need to know something called the 5-number summary. And the 5-number summary is made up of 5 numbers: the minimum, the Q1, the median, the Q3, and the maximum. So if we're talking about the interquartile range, we actually care about the Q3 minus the Q1, and that's why we say that that's that middle 95% of the data, and that's why it is resistant to outliers, because if the maximum or the minimum are outliers, then they're not being impacted. The interquartile range is not impacted. All right, so now we're actually going to get into some AP questions. So if you see an AP question like the one below, I'm going to scroll down a little bit, where it gives you a distribution, it gives you a graph, whether it be a histogram, a dot plot, a stem plot, box plot, whatever, and it tells you to describe the distribution. Describe, you may be like, oh, let me try to, describe it in my own words. No, don't use your own words. Describe in this class means SOX. So what is SOX? SOX stands for shape, outliers, center, and spread. And there's an extra C in here, and you're like, what's that C for? The extra C is in context. So the context is the real life setting of the question. So they don't want you to just write skewed right with one outlier, with a median of this and a range of that. They want you to say everything in the context of the question, okay? So for the shape, you're going to say, is it skewed or symmetric? If there is a gap, you want to say the location of the gap. If there are outliers, you want to name where they are. If you're talking about the center, you want to refer to either the median or the mean, whichever one you have or can easily find. And for the spread, you can use all the different types of spread we said above, but if they don't give you one, the easiest one to find is the range visually. If they give you the standard deviation, you could use that as well, okay? So remember, the measures of center are mean and median. The one the easiest one to find graphically is the median. And then spread is range, interquartile range, or standard deviation. But the one that's easiest to find graphically is the range. And then you're going to all do this in the real life setting of whatever the question is about. So now I'm going to explain it using the question below, which is the AP question, okay? So it says, as part of a study on the chemistry of Alaskan streams, researchers took water samples from many streams with temperatures colder than 8 degrees Celsius and from streams with temperatures warmer than 8 degrees Celsius. For each temperature, the researchers measured the dissolved oxygen concentration in milligrams per liter. So this says this is a graph of the ones with the temperatures colder than 8 degrees Celsius. So keep that in mind. The researchers constructed a histogram shown for the dissolved oxygen concentration in the stream. So this is a histogram. Notice the bars touch. and it is quantitative data because it is numeric. The dissolved oxygen content is measured in milligrams per liter, and that is quantitative data. So keep that in mind, it's numeric. Based on the histogram, describe the distribution of the oxygen content in the streams colder than 8 degrees Celsius. So they want you to describe this graph, okay? So when you describe, what I recommend you do is list the bullet points of SOX and then throw in the context, okay? So let's start with shape. What do you think the shape is? Draw the picture if you have to. What is the shape? I'm hoping that you said it is skewed left because the tail is on the left and most of the data is on the right and the tail is on the left. Okay, outliers. Is there an outlier? Well, I don't know exactly for sure, but I know that there is one here in this bar between 2 and 3 that is separated from the rest, and there is a gap between the 3 and the 4 mark. So I do want to say there is one possible outlier. One possible outlier between 2 to 3 milligrams per liter of oxygen. Center. So let's say I want to find the center. I can't just eyeball it and guess. I am going to find the median. To find the median, I have to do the median formula, which is n plus 1 divided by 2. So n is the sample size plus 1 divided by 2. So did they tell me the total number of streams they used? Let's see. No, it doesn't look like they did. So the first thing that we have to do is total up all the streams and then find the number in the middle. To total the number of streams, you have to total all the frequencies. So in your calculator, you're going to add 1 plus 1 plus 1 plus 13 plus 12, 15. Add all these numbers up and then come back to me with your answer. Okay, so I got 429 for n. So I'm going to do n plus 1 over 2 now. 429 plus 1 over 2. Okay, that's going to be the location of my median. So I got 430 over 2 is 215. Now that does not mean that the median is 215. That means the location of the median is at the 215th data point. So now what I have to do is count my frequencies cumulatively from the left or cumulatively from the right until I reach the number 215 or surpass it, okay? So 1 plus 1, 2, plus 1, 3, plus 13, 16, plus 12, etc. Keep adding until you reach 215, okay? So I'm going to start doing that again here. 1 plus 1 plus 1 plus 13 plus 12. Now I'm at 28, so I'm not there yet. I got to reach 215. So I'm at 12 plus 15. Now I'm at 143. Whoa, that was wrong. 28 plus 15 is 43 plus 40. Now I'm at 83. Keep going. Now add 94. Now I hit 177. Keep going. Add the next one, 117. Boom, we reached 294. So I'm hoping you realize that the median is going to lie in this bar because when I added up the frequencies and I included the 117, I got 294, and 294 is greater than 215, which means that the 215th data point will lie within this bar. So the median lies between 11 and 12 milligrams per liter of oxygen content. Okay, the last thing is the spread. Now remember, because this is a histogram, we don't know the exact maximum or minimum at all. We only know the range or the interval of values. So the maximum that it could be is 14 milligrams per liter, and the minimum that it could be is 2 milligrams per liter. So if we did the range, it would have been 14 minus 2, spread equals range I'm going to write the maximum range would have been 14 minus 2 would have been 12. So at most, the range is 12 milligrams per liter. Okay, so now I'm ready to actually throw in the context of the question because I have all my bullet points lined out, lined up. So I'm going to say the shape of the distribution of dissolved oxygen concentration in streams with water temperatures colder than 8 degrees Celsius is skewed left. There is one possible outlier stream. The median milligrams of oxygen content is between 11 and 12 milligrams per liter of dissolved oxygen, and the maximum range of dissolved oxygen is at most 12. I said maximum, so I'll just say is 12 milligrams per liter. So I'm going to pause it here. I'm going to add all the context in for you, and then I'm going to bring you back. Okay, guys, so as you could see, I just kind of wrote my 4 bullet points that I had written above for you, but in the context of the question, like I had just said. So you see I have the shape of the distribution of the dissolved oxygen content in these streams is skewed left. There's one possible outlier stream between 2 and 3 milligrams per liter of oxygen. The median dissolved oxygen concentration of these streams is between 11 and 12 milligrams per liter, and the maximum range of dissolved oxygen concentration of these streams is 12 milligrams per liter. So again, remember with the histogram, we don't quite know the exact values. We just know a range of values or an interval of values. So that's why we say between two numbers or from or the maximum amount. Also, like when in doubt, just go back and throw in the word streams and oxygen content. And that's how you get full credit on one of these questions. Typically, these questions are number 1 on the free response of the AP. Now, another skill that they might ask you about on the AP free response is instead of just describing one distribution, they may ask you to compare the two distributions to each other. So basically, again, when we're using the word compare, that means we have to use comparative language. So super important with comparative language that you're using keywords like greater than, less than, approximately equal to, etc. Wider than, narrower than, etc. You have to use comparative language. So think about when you're using comparative language in another class like social studies or English, you really have to kind of compare the two to each other. But because it's a math class, we want to use quantitative language like greater than, less than, or about equal to, or unless they're exactly equal to, you could say exactly equal to. So here's an example. So here we have 2 distributions for household size in 2 different countries, South Africa versus the UK. And it looks like they chose 50 students from each country. So the sample size for each one of these was 50. So that's N, sample size of 50. And they asked them how many people are in your household. And then they graphed it in the form of a dot plot. So these are called parallel dot plots because they are kind of written right on top of each other. And the reason why this is nice is because we have the same scale on the x-axis for household size, so we can really easily compare all the bullet points of socks. So you're basically going to do the same thing that we did before with socks, but you're going to use comparative language. So first, what I recommend you do is kind of write the shape, outlier, center, and spread for each one separately, and then you draw comparisons between them, okay? So let's do that. So the shape of South Africa, can you guess what it is? I'm hoping you said skewed right. The shape of UK, it looks like it's approximately symmetric, or maybe skewed left. I'm going to say approximately symmetric for now. So if I had to write a comparative sentence about shape, I would want to say the shape of the household size for South Africa is more skewed than the UK, or the UK is more symmetric than South Africa. So I'm going to do that now. The distribution, the shape of the distributions of household sizes for South Africa and the UK are different. South Africa household sizes distribution is more skewed than the UK, which is more symmetric. Okay, something like that. All right, so that's the comparison of shape. Bullet point 1, S. Next one, we go to outliers. Are there any outliers for South Africa? I'm hoping you're saying yes, one that has a household size of about 26. Are there any outliers for UK? I'm hoping you're saying none. Okay, so that's the second bullet point. One outlier for the SO. This is O. One outlier for this one. No outliers. Okay, so we want to say that next. Bullet point 2. The household sizes, there is one outlier household size, household for South Africa, whereas UK has no outliers, or you could say there are more outliers for South Africa than UK, something like that. Okay, that's the second comparison. Now we go to C, center. When we do center, we could do median. It's easier to find. Now, before you even find it, let me ask you, which one looks like they have a greater median, if you had to guess? If they're both 50 is the sample size, remember if you do the median formula, it would be n plus 1 over 2. 50 plus 1 over 2 is 51 over 2, which is 25.5th observation. So if you count to the 25.5th, you would actually be able to find it. But can you see which one looks like it's just kind of greater than the other one? I'm hoping you're saying South Africa because the center, it's more shifted to the right than the UK. So yes, I could actually find the median for each group, and I actually just did. I counted them all out and I found it. I got the median for the South Africa household size of 6 in the household versus the median household size for the UK to be 4 in the household. So I was right even just by eyeballing it. Now, you don't actually have to find those medians in this kind of comparative question. All you have to do is make a comparative sentence. So all you have to do is say the median household size for South Africa is greater than the median household size for UK. And that's it. That's the comparison. So because I'm using the keyword greater than, I'm using comparative language and I'm good to go on that. And the last thing I want to hit is spread. So remember, it's shape, outliers, center, and spread. So spread can be measured by range. And which one looks like it has a greater range? If you did maximum minus minimum, which one looks like it's more variable or more spread out? South Africa or UK? I'm hoping you're seeing that UK is more consistent, more squeezed together, and more less variable, and South Africa has a greater range. So we just have to say that, and then we're done. The range, or variation, or even standard deviation of household sizes for South Africa is much greater than the range of UK. Household sizes. And remember, you could actually find the range, but you don't have to. You just want to make a comparative sentence. So that's kind of nice about the comparative ones. You can be a little bit more general. All right, so that's that. Now the last graph we're going to talk about today is going to be the box plot. The box plot was last because we needed the 5-number summary in order to make a box plot. And we did address the 5-number summary up above, but I do want to write it again here for you. So the 5-number summary is made up of the minimum, Q1, median, Q3, and maximum. We need those numbers in order to make a box plot. And now it's important to note that we need to find if there are official outliers or not. We're going to use this 5-number summary and apply it to an outlier formula, and we're going to determine if there are any outliers or not, and then we're going to draw our box and whisker. Okay, So this was an AP question that actually just happened in the last year. And it's the same from above. It's continued the question about the streams that we just did. So if you remember, we did the distribution of the dissolved oxygen concentration of the streams with the temperatures with the water colder than 8 degrees Celsius. Now they say, okay, here's the information for the streams that have warmer water than 8 degrees Celsius. So this is a different distribution. For this one, they gave us the numerical summaries. They are also called the 5-number summary, but numerical summaries are just basically numeric values that summarize the data. So I'm going to circle the components of the 5-number summary that we need. Minimum, Q1, median, Q3, and maximum. We don't need anything else just yet, okay? So if we want to make a regular box plot, one that does not show outliers, all we have to do is use the 5-number summary. Now notice it said do not indicate outliers. So that's why I don't need to worry about the outliers right now. I'm just going to use those 5 numbers in the 5-number summary. So here's my advice. Go to these numbers that in the 5-number summary, plot a point or a dot kind of hovering above that number, and don't connect them yet. So I'm going to go to 2.10-ish, plot a point, 4.39, 5.43, 6.12, and 13.45. Okay, once those dots are all written, you can put like little hash marks or dots. What you want to do is draw lines around the middle 3 because this is going to be your, I'm just going to write what these are, even though you don't need to write this on the AP. Minimum Q1, median Q3, and maximum. Okay, you're going to draw lines through the Q1, the median, and the Q3. And this is going to become your rectangle, which is going to be the part of the box. And then you're going to draw your whiskers going out from the Q1 to the minimum and the Q3 to the maximum. So now you have your box plot. Again, you only need your 5-number summary. You don't even need to write minimum Q1, median Q3, maximum. That's really more just for me to explain what you're looking at here, but that's it. Now, does the box plot show exact values? It does not. It only shows the 5-number summary. So I don't know what the value of the values are between the minimum and the Q1 at all in the data set. I only know the 5-number summary. So if I go back over to here, I just want to make a note that it says box plots do not display individual values. So it doesn't show the gaps, the clusters, or any of that. Those kind of pieces of the shape that we would see in the histogram, the dot plot, or the stem and leaf. So keep that in mind. But that was your like regular box plot. I call it a regular box plot, one that does not include outliers present. Okay, so that was on the AP. Now you may be asking yourself, well, what's she talking about showing outliers or not showing outliers? There's an official formula for how we can calculate outliers. In the past, in this video, I just was looking at ones that seem removed from the pack and saying, oh, that looks like an outlier because it's removed from the rest. But there's actually a formula that we can do, and that formula is written here in this box. So the first thing we have to do is find the IQR. Okay, I'm writing it out like here, steps. First, find the IQR, which is Q3 minus Q1. That's the interquartile range, okay? After you do that, you're going to multiply it by 1.5. Okay? And that number, what you're going to do is you're going to add that number to Q3, Q3 plus this number, and you're going to subtract that number from Q1. You're going to get two numbers that are going to be serving as cutoff points. They call them fences or boundaries or cutoff points. Basically, they're going to give you an upper cutoff or an upper fence slash cutoff for outliers, and a lower fence or lower cutoff for outliers. Whatever is below the lower cutoff or above the upper cutoff is considered an outlier, okay? I am going to show you what we do with that right now because I know it's a little abstract if we don't actually do it. So here we go. we are going to make what's called a modified box plot. The modified box plot is the one that shows the outliers, specifically separated from the whiskers, marked by some kind of asterisk, point, etc. So here is an example down below. You see this is the box plot, and then you see that the outliers are labeled here on the right, which I will highlight them in purple. 1, 2, 3, 4 outliers here. And those outliers are separated from the whisker. And what they do is they draw the whisker to the highest number that is not an outlier. So the largest number that is the maximum that is not an outlier, and then the lowest minimum that is not an outlier. So we are going to do one of these so you can see it in practice, okay? So here is some data. We are going to first calculate the 5-number summary. So I think this data is a little different than the last one, so we're going to hit stat edit to double check. It is different data. So first thing we're doing is clearing our list. Second plus sign, 4, enter, clear your list. Now press that at edit and enter your data. And I'm going to pause for a second. We're going to get our 5-number summary. Okay, once your data is entered in L1, now we're going to press stat, go over to calc and choose number 1, 1-var stat, make sure that it says L1 and there's nothing in the frequency list. Hit enter. Scroll down. Do you see here you have your 5-number summary, minimum Q1, median Q3, and maximum. I'm just going to pull this over here so it's easier for me to see. Okay, and then I'm going to tell you how we write it. We're going to write it with little slashes or hyphens between them. Minimum is 8, Q1 is 14, 17, 19, and 38. If you like, you can label it minimum Q1, median Q3, maximum. Now we're going to actually do our outlier formula, okay? So here we go. Step 1, we're going to find the IQR. To find the IQR, we're going to do Q3 minus Q1. So do 19 minus 14, and we get 5. Step 2, we're going to do 1.5 times the IQR. So we're going to do 1.5 times 5. Okay? If you need to, do it in your calculator, like me. 1.5 times 5 is 7.5. Now we're going to do, to get the upper boundary, we're going to do Q3 plus 1.5 IQR. And then to get the lower boundary, we're going to do Q1 minus 1.5 IQR. Okay, so 1.5 IQR was 7.5. So we're going to do Q3 plus 7.5 and Q1 minus 7.5. All right, so Q3 was 19. 19 plus 7.5 is going to be my upper cutoff or upper fence for outliers. And my Q1 was 14 minus 7.5 is going to be my lower fence or lower cutoff for outliers. Okay, so let's do this now and see what we get. 19 plus 7.5 and 14 minus 7.5. So my upper cutoff was 26.5 and my lower cutoff was 6.5. Okay, so now we got to go back to the question to see, are there any outliers? Are there any numbers bigger than 26.5? Yes, I see one. 38 is indeed bigger than 26.5. So 38 is considered an outlier on the upper end. One outlier on the upper end, on the right side. Are there any outliers on the lower end? Are there any numbers that are less than 6.5? And the answer is no. No outliers on the lower end. Okay, so now that we have this information, we're going to be able to make our modified box plot. 38 was the outlier. Okay. So it says down below, create a modified box plot. So just remember our range of values is between 8 and 38. So when you make your horizontal axis, you want to make it go from 8 to 38, but you don't want to count 8. You don't want to put in the numbers only in the 5-number summary, 8, 14, 17, 19, 38. Like who counts like that? We don't. So you want to think about how are we going to count by. So maybe you want to start at 6, I don't know, and then count every 2. 6, 8, etc. So you can play around with it and try to figure out what we're counting by. But you might be here all day if you count by 2s, so maybe you want to count by 5s. 5, 10, 15, 20, 25, 30, 35, 40. Okay, now we want to label our variable that we were measuring. So it says we were measuring the number of Instagram likes for 10 posts by our publisher of our textbook. Okay, so the x-axis is going to be labeled number of likes for the posts. So now we're going to go to our 5-number summary, and I'm just going to put dots for now. 8, 14, 17, 8, 14, 17, 19, 38. Okay, so put a dot floating above each one to start. 8, 14, kind of make them line up if you can. 17, 19, and 38. Now, we remember that you want to start by going to your 3 middle ones and putting lines, and then you want to create a rectangle around those, and that's going to be your box. Now your whisker is going to go to the lowest non-outlier min and the highest non-outlier max. But remember that 38 was considered an outlier based on our formula. So I'm going to make it into a star or an asterisk and basically just leave it there kind of floating. So now I have to go to my highest number that is not an outlier. So the next highest number that is not an outlier is 21. Remember the upper fence was 26.5, so 21 falls under that. So we are going to make our whisker go to 21, the lowest non-outlier min. Okay? So that is your modified box plot. Now, you may be like, can I check this in the calculator? And yes, you can. I'm going to show you how to do that right now. So the way to do it in the calculator is you have to turn on your plot. To do that, you press second y equals. Now remember, my data is in L1, so if you don't have data in there, it's not going to work for you. Hit enter on plot 1, hit enter on the word on, and then go down and choose the third one from the right, which I already have highlighted here. This is the modified box plot. Notice it has little dots separated from the whiskers. That's going to indicate outliers. And then you're going to make sure your list says L1, frequency 1. Okay, I'm going to write that down first. So we press second y equals, we do plot 1 on, and then choose the modified box plot, which is the third one from the right. And then once you're there, you're going to press zoom 9, which is zoom stat. Zoom 9, zoom stat. And let's see what we got. Zoom 9. Now notice I have this red line here. I have something in y equals. So I want to hit clear to make sure nothing's in y equals. And then zoom 9. There it is. So notice my plot. It does look pretty similar to my graph that I made by hand, right? And then what's cool about this is you can press trace, which is on the top right next to graph, and you could go to the right and left, and it will go between your 5-number summary. Minimum Q1, median Q3, biggest number that's not an outlier, 21, which is where we drew our whisker to, and then our outlier was 38. Isn't that nice? So why would the median and the IQR be a better choice in this case to use than the mean and the standard deviation? I want you to answer that question. And now, my friends, I have talked all I could talk. You're ready to run on your own. You're ready to walk on your own. You're ready to run on your own. Here is the AP question that culminates in the skill that I just went over, the modified box plot. It's going to give you a histogram. It's going to ask you to write a few sentences describing. So that's going to be your socks. Remember, you're going to do it in context. Make sure you use the context of the question for part A. Then it gives you the summary statistics, aka your 5-number summary. You're going to use your 5-number summary down below, only your 5-number summary, and you're going to make a box plot. But it says there may be potential outliers, so determine them using your outlier formula, which we just went over. and you're going to plot it. You cannot put this in your calculator because you don't have all the data from the whole data set, so you have to use your 5-number summary. So I'm going to circle it for you. Minimum Q1, median Q3, and maximum. Use that outlier formula that just went over, and then answer part C. You can do it. You're ready, and you're done with chapter 1. Thank you for listening, and I will see you real soon. I look forward to it.